Okay, this is the same setup as before, except I've gone ahead and mounted the negative temperature coefficient thermistor so that it's kind of suspended over that bulb there. And I've just wired it in so that it's across from the gate to the negative rail there. And then I've got the voltmeter hooked up from the gate to the negative rail as well. So the voltmeter is telling us the voltage drop across that resistor, or in other words, the voltage applied to the gate of the MOSFET. And of course we know that the gate of the MOSFET is what is regulating the brightness of that bulb, because we're in the linear conductance region, right? So voltage is a numerical readout for the experiment we're about to do, and the brightness of the bulb is an analog readout of the experiment we're about to do. Now I have the NTC mounted above the bulb. What I'm going to do now is use this tube to blow on the light bulb with my breath. Okay, I can't watch the screen of the camera while I'm doing that, so I hope that it worked out the way that I expected it to. I blew a current of air across the bulb, which of course cooled the bulb and the NTC, and that caused the resistance of the NTC to go up, which allowed the charge on the gate that's coming in through this potentiometer to rise, allowing the MOSFET to turn on more and pass more current to the bulb. Now as the NTC cools off, we get back to the original stabilized value, but I can cool it off, or rather warms up, I mean. As it warms up, we're starting to get back to the value that we had over there. Okay, but I have this little air thing, and I can cool off that NTC quite well with the blast of the air blaster there, and then it warms up again. So I think what we've done here is we've illustrated that we can use a MOSFET in its linear conductance region in a very, very simple circuit to make something as sophisticated as an airflow sensor that can actually monitor a stream of air passing a point. That's just one use of a MOSFET as an amplifier with a feedback loop sensing a parameter of interest, like airflow. I'm going to blow on it again. Okay. So by applying a known airflow across a little fixture there, we could get a calibrated value in volts that is equivalent to some, volume milliliters per second or something of air flowing past our little sensor. Or if we were monitoring, say, the dripping of water, cooling off our sensor a little bit at a time. The possibilities are literally endless. The MOSFET is not just a switch. It's an amplifier, and it can be used as an amplifier. And the basic feedback loop mechanism is ubiquitous in electronic circuitry, especially in circuits that require stabilization of some kind, or circuits that require sensitive sensing. I'm sure the stage musicians and grandfathers among you can think of all kinds of interesting little demonstrations using this phenomenon. Thank you for watching.